Today we're going to talk about quadrilaterals and their properties. And the first property here talks about being perpendicular. The definition of perpendicular is when two lines that meet form a right angle. A right angle is 90 degrees. So here you have two lines that meet and they are forming a 90-degree or right angle. A bisector is an imaginary line that divides a shape in half from the corners. So as you can see here, from corner to corner, diagonally, it is cutting the shape. Cuts it in half this way, and then this imaginary line cuts it in half this way. Congruent is exactly the same size and shape. So if the example over here, these two triangles are exactly the same size and shape, meaning all their angles are the same and all their sides are the same. Adjacent is where two sides that meet at a vertex. Vertex is another word for corner. So for example, here's two sides and they meet at this point. This point is called the vertex. In the example below, it wants you to state which diagonals are congruent. Remember, diagonals is a line that divides the shape into equal parts. So if I draw a line here, if I draw two diagonals in A, are these congruent? Are they the same size? Yes, they are. And you know this because these sides are the same length. So for example, the top and the bottom here are the same length. In example D, you notice how the base of this shape is shorter than the top of the shape. So when you go to draw this diagonal, this one is going to be longer than this one, making it not congruent. Let's look at quadrilateral properties on the next page. Some of these you have seen. For example, this shape here is called a parallelogram. A parallelogram has its opposite sides and angles are congruent. So here's its opposite sides. So the top and the bottom are opposite from each other, so they are congruent, and that is signified by these two tick marks here. Since they are two tick marks, that means any other side with two tick marks are congruent. This side here and this side here, note that they have one tick mark each, which means they're opposite sides and they are congruent from each other because they have the tick mark. Angles, very similar with angles. Notice how there's one notice how there is one, not tick mark, but angular tick mark in the diagonals. Okay, that signifies that these two angles are congruent. Now if you look at the other diagonal angles, there are two, meaning that these two are congruent to each other, but not to the first set. Opposite sides are parallel. So to signify that something is parallel, you'll see almost like arrows. Okay, and since there are two blue arrows on each of these lines, that means these are the two lines that are parallel. Whereas going the other direction, you may see one blue arrow on each of these sides, which means these two are parallel to each other, but not to the ones that are going left to right. Diagonals bisect each other. So if I were to draw diagonals here, remember bisect, bi means two. So this, when they bisect each other, they are cutting the lines in half. So this side here is going to be the same length as this side here. They're going to be equal. In our next shape, this is a rhombus. It is very similar to a square, except it does not require 90-degree angles. So all sides are congruent. So that's, you see 4 single tick marks. That represents all of the sides are congruent. Opposite angles are congruent. So you note that these two are congruent to each other, and these two are congruent to each other. But remember, if it has 2 tick marks and 1 tick mark, that means they are not congruent to each other. They have to have the same amount. Opposite sides are parallel. So you represent that with your arrows. That's opposite sides. And diagonals are perpendicular bisectors. So again, to bisect, bi means 2, so it cuts it in 2. But the word perpendicular, remember, means that it's 2 lines that intersect that are going to create a right angle. So when these 2 diagonals intersect, they're going to create a right angle. The next shape is a rectangle. A rectangle has the same properties as a parallelogram, except for the fact that you have all right angles, or all 90-degree angles, and that your diagonals are congruent. Not necessarily that they bisect each other, but they are congruent, so they are equal in length. Finally, you have a square, which has the properties of a rectangle, which means it also has the properties of a parallelogram. All the sides are congruent, however, so they all have a single tick mark. The diagonals are congruent. The diagonals are also perpendicular bisectors. So very similar to the rhombus, when these diagonals cross, they're going to create a right angle. You also have a kite. This is what a kite looks like. You can think of a kite that you fly in the sky. Adjacent sides are congruent. Okay, remember, adjacent means you have 2 lines that connect to a point. Okay, so these 2 lines are connecting to a vertex here. So these are the ones that are congruent. And then back here, these 2 are congruent. They have perpendicular bisectors. Okay, which means that they're going to create a right angle. I'm sorry, perpendicular diagonals. They are not bisecting, because to bisect it would mean that they would have to be equal, and this half of the diagonal is longer than this half. But they do create a right angle, and they have one pair of opposite angles that are congruent. So right here, these two angles are congruent, but not length going horizontally. Those are not congruent. And exactly on the last shape, you have a trapezoid. Exactly one pair of sides are parallel. So for example, here, these are parallel. Or here, these are parallel, because you can have two different shapes that are trapezoids. An isosceles trapezoid, the diagonals are congruent. This shape here on the left is going to be considered the isosceles trapezoid. And then the bases are parallel. You must memorize your properties of the quadrilaterals. They will not be given to you on a quiz or a test. You have to know them. Now let's look at the rule always, sometimes, never. So this picture here is to help you remember your properties. If in your picture you're going to go up, it's going to be always. From one shape to the next, if you go down, it'll be sometimes, and left to right, it'll be never. You have to memorize this too. So for example, if I go from a square, if I state a square is a rhombus, so here's a square, here's a rhombus. I am going in the up direction to get from a square to a rhombus. So this is going to be always. A kite is a trapezoid. So here's a kite, here's a trapezoid. I am going to a right direction. Well, right is never. This means that a kite can never be a trapezoid, where in the first example, a square is a rhombus. A square has all the properties of a rhombus, so a square can be always a rhombus. And the third example, a parallelogram is a rectangle. From a parallelogram to a rectangle, you are going in the down direction, so that is sometimes. Because remember, one of the big differences with a parallelogram and a rectangle is that a parallelogram is not required to have right angles. But if it does, then it can be considered a rectangle. So sometimes. Pause the video and try the remaining problems on the page. In the below problems, you'll also have to identify what the shape is given the properties. Check your following answers. If you have any questions, ask your teacher.